The minimum 3-foot clearance requirement in NFPA 70E Part applies to equipment that is likely to require examination, adjustment, servicing, or maintenance while energized. An overcurrent device on a generator typically does not require frequent examination or servicing while energized. Therefore, it may not fall under the 3-foot clearance requirement. However, if the overcurrent device is located in a tight squeeze inside a room and there is a risk of accidental contact, then additional safety measures may be necessary, such as barriers or guards. Consider a scenario where a generator's overcurrent protection is housed within a confined space. While routine maintenance might not necessitate live work, the potential for needing to access the device in an emergency or for infrequent testing necessitates careful consideration. The initial assessment should focus on the likelihood of requiring access while the generator is energized. If the probability is low, the strict 3-foot clearance might be relaxed, provided that supplementary safety measures are implemented. These measures could include physical barriers to prevent accidental contact, insulated tools readily available for authorized personnel, and clear, prominent warning signage indicating the potential hazards. Furthermore, a detailed lockout-tagout procedure should be in place and strictly enforced to ensure the equipment is energized whenever possible before any maintenance or inspection work is performed. Regularly scheduled inspections of the generator and its associated overcurrent protection are crucial. These inspections should be documented meticulously, noting any signs of wear, corrosion, or potential failure. Addressing any issues proactively minimizes the likelihood of needing to perform live work. Moreover, consider the training of personnel authorized to work on or near the generator. Thorough training on the specific equipment, safety protocols, and the proper use of personal protective equipment is paramount. Emphasize the importance of risk assessment before commencing any task and empower personnel to halt work if they perceive any unsafe conditions. An example of equipment that is not likely to need servicing while energized is a remote disconnect switch that is only used for emergencies or infrequent maintenance. The disconnect switch is typically located in a locked enclosure and is not easily accessible, so it is unlikely to require examination or servicing while energized. Analyze the operational characteristics of a remote disconnect switch. Such a switch, designed for emergency shutdowns or infrequent maintenance procedures, is typically housed within a secure, locked enclosure, thus restricting unauthorized access. The very nature of its intended use diminishes the likelihood of requiring live servicing. However, while the probability of needing to work on the energized disconnect switch may be low, it's not entirely non-existent. For instance, a malfunction within the switch itself, preventing it from operating correctly during an emergency, could necessitate troubleshooting while energized. In these cases, a comprehensive risk assessment is essential. Firstly, identify the specific tasks that need to be performed. Secondly, evaluate the potential hazards associated with each task, such as exposure to live conductors, arc flash, and electric shock. Thirdly, implement control measures to mitigate these hazards. These measures might include utilizing appropriate personal protective equipment, such as arc-rated clothing, gloves, and face shields, establishing a clear approach boundary, employing insulated tools, and ensuring that only qualified and authorized personnel are permitted to work on the equipment. Furthermore, document all procedures and risk assessments meticulously. A written plan outlining the steps involved, the identified hazards, and the implemented control measures provides a valuable reference for those performing the work and serves as a record of due diligence. Regular audits of these procedures ensure that they remain effective and are consistently followed. Also consider incorporating remote monitoring capabilities into the disconnect switch system. This allows for continuous monitoring of the switch's status and performance, providing early warnings of potential problems. This proactive approach reduces the likelihood of needing to perform hands-on maintenance while the switch is energized. It is also important to consider the specific environment in which the electrical equipment is located. Factors such as temperature, humidity, and the presence of corrosive substances can significantly impact the reliability and lifespan of electrical components. Implement preventative maintenance programs tailored to the specific environmental conditions. This might include regular cleaning, lubrication, and inspection of connections to prevent corrosion and ensure proper functioning.